We're going to go into some real detail now about how the switch works. Let's start with the fact that the switch can do multiple simultaneous conversations. So here I got PC1 talking to PC5, PC4 talking to PC3, all simultaneously. There are no collisions because remember, each of these devices is on its own collision domain. Now, how do we get information through the switch? There are really three methods that we can use. And by the way, earlier the hubs and bridges did it this way, store and forward. Well, no, hubs did not. Bridges did store and forward. So here's some data coming out of PC1. It is collected until the entire frame gets into the switch, and then the switch can check it for errors and then send it on out to PC number 2 over here. That's store and forward. It's a little bit slow this way because you have to collect this data and check it for errors first. What can we do to make it faster? Well, something called cut through. This stream of data comes out here and the switch immediately begins sending it on. As soon as it gets the address information, sends it on to the next device. That's called cut through. Well, now this is a lot faster, but what happens about these errors? Well, we have a compromise, and that compromise is called fragment free. This is the way we do most of it today. This information is coming out of PC1, and it only stores it long enough to get that source address. And not just the source address, by the way, but I should say the first 64 bytes of information. Well, since the 64 is the minimum size of a frame, that means many frames are going to be 64, but if it's larger than that, it's just going to go ahead after these first 64 bytes and send that on out. So we get faster speeds, and we reduce the chance of errors, although we don't eliminate it completely. Here's something else that switches can do that bridges, by the way, did not do, and that is something called QoS, or quality of service. So I can configure these ports such that certain types of information, say video information or phone information, is faster and gets a higher priority than, say, web pages down here at a lower priority and lower speed. So that's called QoS, or quality of service. Now we're going to look at the ways that different devices can talk to other devices across a switch. They can send unicast traffic, one-to-one, just like we've been seeing in our star topologies for the switch. They can also send broadcast traffic, one to everyone, and we do that by sending it to the MAC address FF. And so then the switch knows, oh yeah, this is a broadcast address, I will send it to everybody. We can send out multicast information. So I can send it to some but not all, just as the subscribers here, but not everybody. There's another one under my picture there. Not everybody, but the ones who want it. Now the way I do that is, again, through addressing. So I've got this 01005E at the beginning of the MAC address and then something else at the end of it to identify this group of subscribers. Now there is one other type that looks a little bit like a broadcast, but it's not, and it's called flooding. And this is something that the switch initiates. Now back here, the broadcast is initiated by this PC over here by using this MAC address. But in the case of flooding, the PC does not instigate that. The switch itself instigates it. So we're going to describe this in more detail in a minute, but the idea is if this device needs to find out who owns these other devices, who are these other devices and what ports are they connected to, it will flood a frame to everybody and until it discovers it, and then it'll start doing the one-to-one unicast stuff. So notice, by the way, that it sends out every port except the port on which it came in. It does not flood it out that port. All right, so let's go through that process of this host discovery. So here we've got PC1 with AA, and so forth, and PC2 with BBBB, PC3 with CCCC. I've got this port 1, port 2, and port 3 on the switch. So now the first PC here says to the switch, hey, I'd like to say hello to BB, please. Alright, so the switch says, let me see, that was from AA, and it was on port 1. So I'll just go ahead and make a note of that, and it makes a little note here. And this is called the MAC address table, by the way, also sometimes called the CAM table, content addressable memory. So it puts a little note in its CAM table or its MAC address table that says, hey, port 1 is connected to AAAAA. And notice it gets it from the source address first, not from the destination address. Now, it doesn't know where BBBB is, which is what A wanted to talk to. So what's it do? Well, it floods the information out of every port except the port on which it came in and says, hey, who's got BBBBBBBBBB? And so PC2 is going to hear that as well as PC3. PC2 now goes, oh yeah, that'd be me. That's me. I got BBBBBB, and it sends that information back to the switch. So the switch says, okay, let me just write that down here. Port 3 is connected to BBBBBBBB. So now it knows this information. From this point on, it will no longer have to do that flooding thing in order to get that information anymore. It now knows who is on port 1 and who is on port 3, and so these guys can communicate all they want after that. So at that point then, the switch can now send that message on to this workstation, PC2 over here with BBBBBB, and says hello, which is what the original PC wanted to send to it. And that's it for how switches learn who the hosts are, the host discovery method.